So it's been a little while since I've done a repair video. So we have here an Atari Lynx 2. I don't actually have mine up at the house at the minute as a spare, so let's see what we can do with this without anything to compare to. I've just gone ahead and whipped the shield off, which takes a while, and stripped the console down. And if we just take a look at what's wrong, we have a chat going on our Discord, and it's basically an Atari Lynx 2. The issue seems to be it turns on then off, which I know these for a fact won't turn on without a game in, unless we do some extra work. So it could just be a dirty game. It could be a power switch. The ribbons often fail. But basically the diagnostic says it turns on and off. So let's just take a look. There's not much to go off there other than it's simply not working. So with the Lynx, what I like to do first is obviously strip them down, take them apart. So we're not dealing with the screen, similar to a Game Gear. Try to ignore the screen to start with, the backlight to start with. What we want to try and do is get potentially some game audio. And even before that, we want to check some power draws. So with the board just stripped down, and I probably don't need to take the shield off, you don't always need to get here. But in the essence of saving time on a video, if we have to, I've gone and got that shield off for us. So I'm just going to get my bench power supply and put it straight on the battery terminals. This will also remove the potential chance that the battery spring box here, this sort of join here for the batteries being the problem, or flat batteries. It kind of removes all those possibilities and you are directly powering the board from a known working bench. And if we hook the 9 volts to here, we won't get anything at the minute, but all we need to do to start the console up is to short between TP17, which is here, and TP18, which is here. So if we just go over TP17 to TP18 and touch on, and we take a look at the power draw, you can see we've got 120 milliamps at 9 volts, which is just over a watt, which is pretty much a working power draw. So I've just got a known working game in here of mine, which is Rampart. So I know this works and I know it plays audio. The thing you'll find with the Lynx normally, and I think some revisions are different, but if we try that again without any game inserted, and short between TP17 and TP18, you can see the power draw isn't moving. It will not start up at all. So if you don't have a known good working game, it won't power up at all, which is a pain. So just to eliminate that, so we don't have to have a game in for this test, and we don't have to rely on all the RAM working, part of the circuit can be completely ignored then, because we're not relying on a working game. We're just going to rely on potentially the insert game screen. Is if you take the metal cage off so you can access the pins, just bridge pin 33 and 31, which are these two lower pins here. There's no need for a wire for this, you can just simply bridge it with solder. And there's your join. And I don't really know of any reason not to do this, and just leave it as a permanent fix on the board. Just clean up that residue. So what that will do now is allow us to power this with no game inserted. So we have no game in. If we just connect the power back up, and this time if we short between pin TP17 and TP18, you'll see that the console boots. So we're getting the 100 milliamps. And that's without a game inserted. So I'm pretty confident this is actually booting. And what it might be is the ribbon. So what we're doing when we're bridging TP17 and 18 is we're doing the same thing as taking the actual console and pressing the on-off button, because that bridges those two pins ultimately. If we took a look at the schematic and looked at what we're doing, you can see we have a power on, which is TP17, and an on low at TP18 here, which is in essence the same as shorting the ribbon. If we went to the actual ribbon, you can see what we're doing is shorting power on and power common together on pin 6 and 7 of this cartridge connector. So another way you can do it is starting at pin 1, which I believe is here. Yeah, so pin 1 here. You can count up 6, so you can go 1, 2, 3, 4, 5. So 6 and 7 are here. If you bridge these two, it does the same thing as shorting out. But I just tend to find it's easier to get a pair of tweezers that just rest over and stretch between these 2 points here to start the console. And all this entire power circuit does is effectively enable Q12 to allow ground to enter the system. So the way the Atari works is it disconnects ground from the rest of the system. Whereas most of the time, power is sent to the system, like 5 volts or 9 volts. It's not normally that the power is always present and simply ground is missing. But on the Atari, it's a ground switch system. So a third way we could do it is to short out on Q12 here. You can see we've got gate, source, and drain. So the way to bypass that circuit is also to just short over these 2 pins. So there's many ways to turn on the system. But now it's on, let's put the game in and see if we can hear audio. So we've got the game in. Go on here. And we will have to connect the speaker. So the speaker's inside here, still attached to the shell. I'm just going to attach the speaker to the speaker pin here. So now the speaker's attached. Let's see if we can power the system. Just bear in mind when you power this up, all this here is high voltage, like 400 volts driving the backlight. So do not touch under here, around this area, kind of down this line. Don't touch anything that side of the board or you'll get a nasty belt. It's not going to kill you, but it's certainly going to hurt. Let's turn the console on, joining TP17 and 18. And this is the benefit of having a bench power supply. You can actually see the console is definitely booted based on power draw. It tells us a lot about the system. But I'm not hearing any audio. Make sure the volume wheel. Yep, that's up. I'm not hearing audio. So maybe the game isn't loading, or maybe the speaker's bad. So let's just check the speaker, which is an easy check. Speakers are normally 4 ohm or 8 ohm, and it's basically a coil of wire that vibrates and causes a magnetic field to pull the diaphragm in and out to vibrate the air. So all we care about in terms of how this works is the speaker itself should have 4 or 8 ohms resistance. So multimeter into resistance mode. You can see short them out, you get 0 ohms. And probe over the speaker and we should get between 4 and 8 ohms. And we're getting absolutely nothing. So this is completely a dead speaker. So either the wire is physically broken just here to there, which I think that's insulated anyway, but no, so the wire is good there to there. Is the wire good here to here? Because if it was just a break between this part of the circuit, we could potentially repair the wire right where it stands. Nope, they're both okay. So the speaker's dead inside. Part of this coil inside here will be dead. For that, I'd recommend just getting a Game Gear speaker. That's currently the closest speaker we have that fits. Just clip it out and attach a Game Gear speaker in. So that's dead. So let's just solder on then a speaker directly to the actual board. So I'm just using the universal Game Boy speaker that we sell. It's good for most things. It's 8 ohm, so it will definitely be okay. Sometimes you just have to bear in mind if you use 4 ohm speakers on a circuit designed for 8 ohms, it would possibly pull twice as much power as the system intended. But 8 ohms you're safe to pretty much assume in every system, that's fine. Now we have the speaker on, let's get that power back on. We've got the game in still, and let's see if we can hear audio. If we hear audio, we know the system's at least booting and functioning, and we can then move on to test the ribbon and the screen. There we go, system's booted. You can see the power draw, and I think it takes a few seconds for the game audio to kick in normally on Rampart. And there you go, there's the game audio. So the system is running, and we haven't had to use any fancy tools other than a bench power supply to really figure this out. So that's a really good sign. So we know we need a new speaker. Now let's see if the screen works. So we can leave our speaker plugged in. This is the backlight, so we'll need this to see. It will actually generate the tube light to light up. If this is broken, we can just shine a light. You can normally see the screen without any backlight. But if the backlight circuit's broken, this won't light up. And in fact, we could even start with that for the minute. Plug that in. Power that on. And let's show you what the backlight looks like. So you can see the difference between on at the minute, and the screen looks like it's partly damaged. But when I turn it off, see how you can see the difference in the screen? So if you watch the screen as it turns on, even without the ribbon connected, this is just the backlight coming on. You can see visually that it becomes evident the backlight's working. On camera it's harder to see, but as you can see in this, there is a light shining. You can obviously do the other thing as well, which is to just look through the tube, and you can see the light is lit up there. So if we cover that, you can see that light is lit up there. And if we were to turn off, you'll see the light goes off. So obviously it's now dull in there. So we know the backlight's good. Let's now connect, we might as well connect then the screen and the ribbon, and let's prove them both at the same time. If the ribbon's bad, we do sell new ones. If the screen's bad, I think Ben Ven has a screen. We haven't made a clean screen for this yet, we just haven't had time. But there are replacement screens available. But hopefully, the screen is all good, and maybe the speaker was dead, and the game was dirty, or something like that. But let's just see if we can get a full boot. I tend to find the easiest way to get these in is to rest the screen down and tilt the board at a right angle. They're finicky to assemble and disassemble at the best of times, but I found this is the simplest way. I'm not going to click them down for now because we're going to be removing this, but it should make good enough contact for the test. So those are in. The speaker's not going to connect because it's dead anyway. And now, if we are careful enough, we can turn this over, rotate it down, and now we should be able to attach power on the inside and the ground here. And now testing this, we'll be testing the screen, the backlight, and the ribbon all at once. And there you can see the screens come on. Rampart takes a few seconds to boot. There we go. So we have a fully booting console. So the issue we've seen so far is the speaker was bad, and that's actually the only issue. So the only issue we've really observed so far is that the speaker is dead. And we've also shorted the pin to allow this system to boot, pin 31 and 33 together, without a game. Now just turn that off a moment. So let's just test this without a game. Turn on. And you can see we get the insert game. Now, some systems show this without the pin bridged. I have seen that it does happen on a few consoles, but most do not. Just testing a few power cycles. So the on and the off work. So it does seem to be working. I will send a new ribbon cable back as well, just because I know these ribbon cables often fail. And maybe me simply disassembling this first and reconnecting this ribbon cable has made this ribbon cable work. Maybe it was that the game the customer has is dirty, so it would never boot with a dirty game. And by adding this join, it allows us to see if it's going to work or not. So my suspicion is the customer has a dirty game cart pins here that need to be cleaned with a pencil eraser and some IPA. And for good measure, I'll also just clean the cartridge pins in here. And I don't think it needs anything aggressive because it's loading my games fine. So the simplest way is to soak the game in IPA and then remove and insert the game 20 times to effectively get this alcohol onto the gold pins in here and just give them a light clean. So now, regardless of the customer's game, this will boot up and it will show something. I'll place a new speaker in as well. I'll just chuck a Game Gear speaker in here and reuse this cable. I'll chuck the new ribbon in just for the sake, so everything's all fresh. And then if it still doesn't work when this is returned, the only thing left to check would be here, which is blatantly obvious that it's very clean. But just to do a quick check on that, you could just take your multimeter and measure the resistance between where both batteries would touch if they were installed into this. And you can see we get less than an ohm. So this is definitely good. The console definitely boots. It'll boot now without a game. I'm going to refresh the ribbon so we know that stays working for a longer time and install a new speaker. And this should be all good to go. So my suspicion there, as mentioned, is just simply these consoles don't generally boot without a game, and a great way to bypass that is to simply bridge this pin, and it allows you to test the rest of the system without having to have a game in and worry about whether it's the game, the RAM, something to do with processing the game data. At least you can then turn on and look at a screen and see if you see the insert game screen, or use a bench power supply and see if you see the power jaw going on and off when you're pressing the power button. So to check without a ribbon, you can join TP17 to 18. To check without that speaker, you can solder your own on. And to bypass everything except the power on circuit, you can simply look at the bench power supply to see what it's drawing. So that's it for this one, guys. If there's any other consoles you want to see me repair, let me know, or send them in to me, and I'll do a video on repairing them.